Hi, Mr. Causey here. Here's a question that involves solving a trig equation. 7 sine x degrees plus 2 equals 3. Ask yourself what you would do if you were faced with solving an equation like 7s plus 2 equals 3. Would you not subtract 2 from both sides and then divide by 7? And that would be you having solved a normal algebraic equation. This is a trigonometrical equation. It's got a sine x instead of this variable s. But let's go ahead and do precisely what we've just done, but in this equation. So we'll treat it as an algebraic equation first of all, and look at the actions that we would take to both sides. First action would be to get rid of that 2. We do that on both sides so that these two terms will still be equal. Same action, both sides. So we'll be left with 7 sine x equals 3 minus 2 is 1. Same action to both sides. 7 lots of what we want, so we undo that times 7 by dividing both sides by 7. So that results in 1 sine x, the 7 disappears, and 1 divided by 7. So we've done precisely what we did in this algebraic equation to this trigonometric equation, and got a value for sine x equals a 7th. So how do we proceed? How do we find an angle whose sine is 1/7? Remember, the sine function has values between 1 and -1, and we're interested in a 7th there and there. Now these are the quadrants, 0 up to 90, 90 to 180, 180 to 270, 270 to 360. We'll only find the sine, an angle whose sine is a 7th in the first and the second quadrants. Now another way to do this, you'll probably have been taught this diagram where all three functions, the sine, cos, tan, are positive in the first, only the sine's positive in the second. In this, sine x is positive in first and second quadrants. That's what these two different ways of doing it tell us. There's the sine graph where it's above. There's positive above the x-axis, positive values only in the first and second quadrants. Or in this diagram, sine's positive in here and the sine's also positive in here. So let's find the first quadrant angle. And then we can bother about how on earth we find the second quadrant angle in a wee minute. So the first quadrant angle is, the sine of an angle is 1/7. Now on your calculator, and for goodness sake make sure that that's deg, not GRD, not RAD, that it's in degree mode, or you'll get the wrong answer. And we don't press the sine button, we do the opposite of the sine button. That's either sine to the -1 or second function sine. You'll know your calculator, but in this one it says a sine, and that's asking the question, what angle has a sine of 1/7? What angle has a sine that has a value of 1 divided by 7? That's how I do it in this calculator, making sure you're in degree mode, and the answer is that is the angle. So the first quadrant angle is 8.21 degrees, and I'm putting that down just now to 2 decimal places, or 3 significant figures in there, 2 decimal places just now. So the first quadrant angle is 8.21 degrees. So that's the angle we're after, 8.21. Or, well, how on earth do we get the second quadrant angle? Now you look at this sine graph diagram. Along here we know that's just over 8 degrees. There's 180 degrees. Symmetry would tell you just come back from 180 degrees by the same amount, or 180 minus the first quadrant angle. You might know this as a sometimes called a butterfly diagram. If you know this angle here, you go all the way around to 180 and subtract it to get the second quadrant angle. You can see that in this graph diagram or in the quadrants diagram. So whatever way you've been taught this, we know it's 180 minus 8.21 degrees. Now on our calculator, 180 degrees minus that answer, and there it is. It's 171.7. Now I'm rounding it to two places at 79 degrees. So these are the two answers. Normally you would, in this case, since there's no evidence of what they're requiring for accuracy, usually for degrees you'd give it to 1 decimal place. So the solution is x equals 8.2 or 171.8, and that's to 1 decimal place. So that's our two values for x, solving this equation. So that's Mr. Carsey signing out, and thanks for watching this video.